Okay, let's talk about the laws of logarithms. And let's say we had something like the following that we were supposed to expand. So I have the natural log of x squared over the cubed root of x squared minus 1. Okay, so the first thing I know is I use the law that says the natural log of a over b equals the natural log of a minus the natural log of b. So I'll get the natural log of x squared minus the natural log of the cubed root of x squared minus 1. Now I can use natural log of a to the b equals b natural log a to bring this 2 out in front. So I get 2 natural log x minus, and I remember that the cubed root of x squared minus 1 could be written as x squared minus 1 to the 1/3. So this is the same as x squared minus 1 to the 1/3. So I can bring that 1/3 out in front, and I get 1/3 natural log of x squared minus 1. But I'm not done yet. If I want to expand this as much as possible, I remember that I can factor the difference of squares as x squared minus 1 and to x plus 1 and x minus 1. So just remember that. So or like x squared minus 49 would equal x plus 7, x minus 7. And that's just the difference of squares. So I could write this as 2 natural log x minus 1/3 natural log of x plus 1 times x minus 1. Well, now I can go back and I can use the rule of logs that says that the log of a times b equals the log of a plus the log of b. So this is 2 log x minus 1/3 times the log of x plus 1 plus the log of x minus 1. If nothing else in calculus, get good at using parentheses. Don't leave off parentheses, because if you do, your expressions are going to be incorrect. This minus 1/3 is multiplied times everything in here. So then our final answer is 2 log x minus 1/3 log x plus 1 minus 1/3 log x minus 1. And that's our final answer for that one. Okay, now let's say we need to go the other direction, and I have something that I need to combine. So I've got, say, something like 5 log x minus 2 minus the natural log of x squared, let's see, minus 5x plus 6, and then plus 2 times the log of x minus 3. And I want to try to combine this. So I remember that things that are subtracted end up in the denominator, and things that are added end up in the numerator. But first, let me take care of these numbers that are out in front. So this is the natural log of x minus 2 to the 5th minus the natural log of x squared minus 5x plus 6 plus the natural log of x minus 3 squared. So I can now write this as the natural log of x minus 2 to the 5th times x minus 3 squared over x squared minus 5x plus 6. But I'm actually not done here, because I can factor that expression in the denominator. That expression factors as you think of two numbers that multiply together to give positive 6 and add together to give negative 5. So that would be x minus 2 and x minus 3. So then I can cancel this x minus 2 with one of these, so I'm left with 4 of those. I can cancel this one with one of these. So then I have the natural log of x minus 2 to the 4th and x minus 3, just x minus 3. So now I've condensed it to one logarithm. I'm not going to multiply this out because this is just to the 4th power. If it was to the 1st power, I'd probably multiply it out.